So in this question, we are presented with a free body diagram, and we are given the fact that there is a W10 by 22 steel beam with yield strength of Fy equal to 50 KSI as shown in the figure, and it's only braced at the center of the span. The design method is going to be LRFD, load and resistance factor design. And the question is asking for the design moment capacity phi mn of the beam is most nearly. And we have four options, A through D. So I've set up the screen similar to how you're going to be tested in the CBT, or the computer-based testing format that NESIS uses, in the sense that I have the problem on one side of the screen, and then I'm able to pull up the reference manual or the code of interest on the other side of the screen. So what I've gone ahead and done is I pulled up the AISC manual on my right-hand side here, and I've gone to Chapter 3 for design of flexural members, because that's exactly what this question is asking about. It's asking about the moment capacity phi mn of the beam. So flexural strength is given in section 3-4, and then there's also a number of design tables which we're going to use whenever we can. So the flexural design tables are given in 3-9. So let's scroll down to that section. And we're going to find a very important equation, right? Phi mn, equation 3-4a. Now, I would almost strongly suggest that you memorize this because it's going to come up over and over again. And that equation is going to be popping up on the screen right here. It says phi mn is equal to CB, which is the lateral torsional buckling modification factor, times phi mp, which is the plastic moment capacity, minus phi bf. And phi bf is essentially a simplification of the AISC specification equation F2-2. What it does is it essentially accounts for the slope of the straight line between LP and LR. So it's a simplification of this right here, and it's given as BF is equal to MPX minus MRX divided by LR minus LP. And all we have to really concern ourselves with is that it's given in the design table 3-9. And then we have that BF is multiplied by LB. LB is the actual unbraced length of our beam, and LP, which represents the unbraced length up to which yielding would control over LTB, or lateral torsional buckling. So it sounds like a complicated formula, but it's really not. And what we can do is start plugging and chugging, right? So the first value that we need to find is CB. And CB is going to be equal to 1.0. And the reason I say that is because we are going to use the selection by ZX, or the plastic section modulus. And if you go to the end of this first paragraph right here, CB is taken as unity when we're using table 3-2. Okay, so now we need to find phi MP, and that is simply a lookup. So let's use our table, our first design table, selection by ZX, section table 3-2, and we're going to go down to page 3-26 to find, for a W10 by 22, what phi MPX is. So for a W10 by 22, we look at phi MPX and it's equal to 97.5. Okay, now what is phi BF? Again, that is simply a table lookup. So phi BF for a W10 by 22 is equal to 4.02. Okay, now LB, right? LB is the actual unbraced length. And we're told here that the beam is only braced at the center of the span. So where it's braced is the unbraced length. So center of span in this problem is going to be 20 feet divided by 2, right? So you have to be careful. It's not braced at 12 feet, right? 12 feet is just where the load, the applied load P is. It's braced in the center of span, which would be 10 feet. So watch out for little details like that when you're on your exam and you're moving quickly. So LB is equal to 10. And then LP, another simple table lookup for this beam, W10 by 22, is equal to 4.7, right here, 4.7. Okay, now with that said, we can start solving our equation. So what is phi mn? Well, it's equal to CB, which is 1, times phi MP, which we said was 97.5, minus phi BF, which we said was 4.02, times LB minus LP, times 10 minus LP is 4.7. And we plug that into our calculator, we're going to get that phi mn is equal to 76.19. Now, that answer is going to be in kip feet. And then the other thing that we want to check is this question: is LB, our unbraced length, greater than LP? We want to make sure that LB, the unbraced length, is 10 feet, is greater than that distance where yielding would control over lateral torsional buckling, right? So that would be LP is 4.7. And the answer is yes. So we are good. Phi mn is equal to 76.19, and that would be most nearly choice B, right? So our answer in this case is choice B.